Hello students, today you will come to know about the chemical bonding. But before studying the chemical bonding, there is a question that why actually atoms form bonds with each other. Like as you know, noble gases in the periodic table, they do not form bonds with any other atom. They are stable as in the atomic state. While rest of the atoms, they need to form the bonds. Why? There are two reasons behind that. The first reason is that to complete the octet rule. Now, what is meant by octet rule? If the atom has the 8 electron in its outermost shell, it means its octet is completed. And this is the reason that why noble gases do not form bonds with any other atom because its octet is already completed. And the second reason is that whenever the bond is formed, it means the atoms are going toward the lower energy state because whenever the bonds are formed, energy is released and resulting molecular compound is more stable than the individual ones. So there are four types of chemical bonding. There are four types of chemical bonding. The first one is ionic bonding. Now, ionic bonding is what? Actually, the bond formed when electrons are transferred from one atom to another, and normally it is between metals and non-metals. Why? Because metals have a tendency to lose electrons and non-metals have a tendency to gain electrons. So therefore, as there is a complete transfer of electron from one atom to another, so therefore this bond is formed between the metal and the non-metal. For example, NaCl. Now the next type is covalent bonding. So covalent bonding is formed by the sharing of electrons between the two atoms. And normally it is between the non-metals, both are needing the electrons. So therefore, they just share the electron to complete their octet. Now the third type is metallic bonding. This bonding is formed between the metal atoms where the electrons are shared in a sea of delocalized electrons giving rise to metallic properties. Like copper, iron, sodium, there are a lot of metals in the periodic table. Now the last type is the coordinate covalent. This is the subtype of also covalent bond. So basically what happens, the one atom donates a lone pair of electrons and another atom has the empty orbital to accept the electrons. So for example, bonding between NH3 and H positive. As you can see, H positive is electron deficient, while NH3 has the lone pair of electrons to donate. So therefore, this type of bonding in which one atom is donating the electrons while other is accepting the electrons is coordinate covalent bond. Now first of all, we will go into the detail of ionic bonding. So ionic bonding is usually formed, as I told you, that it is formed between the metals and the non-metals. So therefore, electrons will be completely transferred from the metal to the non-metal. And a strong electrostatic force of attraction is created between the positive and the negative ions in the crystal lattice, which results in the ionic bond. So ionic bond is sometimes called electrovalent bond because this is formed due to electrostatic forces of attraction between the two atoms, between the two ions basically. So So in the first example, as you can see, the bond is formed between Na and Cl. So as you can see, sodium has only one electron in its outermost shell. So therefore, sodium tends to lose the electron. So as you can see in this example, the bond is formed between sodium and chlorine. Now, how this bond is formed? Basically, sodium has one electron in its outermost shell. And therefore it just want to lose this one electron so that it can lose the electron, it can lose the outermost shell, and finally it can contain the 8 electrons in its outermost shell. Okay, now the second thing is that chlorine has the 7 electrons in the outermost shell, so it just need one electron to complete its octet, so therefore it will try to gain the electron. So whenever they will form the bond with each other, the electron that is lost by the sodium is just gained by the chlorine. So the bond will be formed by the complete transfer of electron from sodium atom to the chlorine atom, and the electrostatic force of attraction between the positive and negative ion is actually ionic bonding. Now, in the next example, as you can see, this is magnesium. Now, the inner electrons of magnesium are not drawn here. And as you can see, magnesium has two electrons in the outermost shell. So, it will just lose these two electrons, and these two electrons will be gained by the oxygen atoms because oxygen has six electrons in its outermost shell. It means that it needs two electrons to complete its valence shell. So therefore, what will happen? Magnesium will lose two electrons and oxygen will gain two electrons, and it will have positive 2 and negative 2 charges respectively. So the bond will be formed between magnesium and oxygen. It is magnesium oxide and it is also ionic bond. The second type of bonding is covalent bonding. So it is formed between two non-metal atoms, and when they combine together, they share the electron pairs. And if only one electron is being shared, this is called single covalent bond. And let's take the example of chlorine, Cc, and HH. So how this bond is formed between two chlorine atoms? So both the chlorine atoms need one electron. So it means that what will happen over here? The two chlorine atoms and their orbitals will overlap to such an extent that the electron of this chlorine atom will also under the influence of the attraction of this chlorine atom. And the electron of this chlorine atom will be under the attraction of this chlorine atom so that the electrons have been shared. So this is the example of the sharing of the electrons. The second example, as you can see, hydrogen atoms. Two hydrogen atoms, they need one electron to complete their duplet. In the previous slide, I told you about the single covalent bond because chlorine atoms and hydrogen atoms, they needed just one electron to complete its valence shell. So therefore, they just shared one electron and they formed the single covalent bond. Let's take an example of oxygen. Now, oxygen has six electrons in the outermost shell, as you can see over here. It has six electrons in the outermost shell. It means one oxygen atom needs two electrons to complete its valence shell. And similarly, the other oxygen atom also needs two electrons to complete its valence shell. Now, what will happen? Each oxygen atom will share two electrons so that it can form the double covalent bond. Why? Because as you can see over here, that if they share just one electron, their outermost shell will not be completed. So they need to share the two electrons so that it can form double covalent bond. And now you can see, you can count the electrons like 1, 2, 3, 4, 5, 6, 7, 8. Now each oxygen atom has completed its octet rule by sharing two electrons. So it depends upon the need of the atom that how many electrons does it need to complete its valence shell. So such number of the multiple covalent bonds will be formed. The second example, as you can see, carbon dioxide. Now, carbon has the four electrons in the outermost shell, and carbon needs four more electrons to complete its valence shell. So, what will happen? Now, it will form bond with two oxygen atoms, and each oxygen atom share two electrons, and the other oxygen atoms also share two electrons. Now, what will happen? When the two electrons have been shared, it means the single carbon formed the four covalent bonds because it needed four electrons to complete its valence shell. So as you can see that the number of covalent bonds depend upon how many electrons does it need to complete its valence shell. Now in the third type is a triple covalent bond. Now as you can see, atoms can also bond together by sharing the three pair of electrons. Now let's take an example of nitrogen. Now nitrogen has only 5 electrons in its outermost shell, and it needs 3 more electrons to complete its valence shell. Now what will happen? Basically, each nitrogen atom, now it needs 3 electrons are being needed. So therefore, it will form 3 covalent bonds by sharing the 3 electron pairs. So therefore, as you can see over here, that each nitrogen atom is sharing 3 electrons. So it is forming the triple covalent bond. Third type is coordinate covalent bond. Now, what is coordinate covalent bond? As its name suggests that there is some coordination. Now, coordination between what? For example, if we are having an atom that is very much electron deficient, its orbital is empty, while other atom contains electron pair or a lone pair. Now, what will happen? That a coordinate covalent bond is formed between the two atoms And one of the atom has a lone pair of electrons, other atom have unfilled orbital to accept the lone pair. In other words, the other atom is electron deficient compound. As you can see over here, that nitrogen has a lone pair of electrons. Now you can see how many electrons are present outside the nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Like its octet is completed. But this hydrogen in the vicinity of the NH3 is electron deficient. So what will happen? Nitrogen says, okay, I can share you the electrons and we can form the coordinate covalent bond. What will happen? Both the electrons are being shared to the hydrogen atom and they form the coordinate covalent bond. But again, just keep this thing in mind that coordinate covalent bond is not the complete transfer of lone pair to the electron deficient atom. It's only the sharing as like of covalent bond. So coordinate covalent bond is not completely covalent. Why? Because in covalent bond, both the atoms share the electron pair. But in coordinate covalent bond, only one of the atom is sharing the electrons. Now the next example is very interesting. AlCl3. Now two AlCl3 molecules are there. And you know, aluminium has, as you can count electrons outside the aluminium, these are 1, 2, 3, 4, 5, 6. Only 6 electrons are outside this aluminium. It means that it is electron deficient. And other AlCl3 is also electron deficient. Now what happens? There are lone pair of electrons outside the chlorine. Okay, now what happens that these electrons outside the chlorine will donate as electron to this aluminium, and in the similar way this chlorine atom shares the electron pair to this aluminium, and as you can see that this coordinate covalent bond is shown by this arrow. It means that electrons are being transferred from chlorine to the aluminium. So arrowhead is toward the electron deficient atom. It means electrons has been shared between this chlorine to this aluminium. So this is a very interesting example. As you can see over here, the three bonds are covalent while the fourth bond is coordinate covalent bond. Now the last type is metallic bonding. So as the name indicates, this bond will be formed between the metal atoms. So as you know that metals have the tendency to lose electrons. So let's take an example like sodium. So for example, there are a number of sodium atoms and they have tendency to lose electron. Obviously, they will lose the electron. And when they lose the electron, they will have a positive charge over it and sodium loses just one electron. So therefore, it will have plus charge over it. These electrons are not just confined to their atom, but they will become delocalized. They will move in the whole structure. So therefore, it is called sea of electrons because electrons are constantly moving. And this property is very much interesting and it is because as you know, metals conduct electricity. Now, why they conduct electricity? Reason behind that is these delocalized electrons. Connected through the battery, the electrons, the delocalized electrons will move from one terminal to another terminal and therefore it will conduct electricity and also conduct heat. So this property make it a very good conductor of electricity and heat. So this is very interesting. This is also an electrostatic force of attraction between the positive ions and the electrons. And therefore, it's a very strong metallic bonding is very much stronger. The reason behind that is also electrostatic force of attraction between the positive ions and the electrons and the delocalized electrons. Okay, so this electrostatic force of attraction acts in all direction. Okay, as in the ionic bond. So, the strength of metallic bonding increases with increasing the positive charge on the ion because you know, the more the positive charge, the more is the electrostatic force of attraction between the positive ion and the electrons. And similarly, the size of metal is lesser. It means there will be less shielding effect. And the positive ion will attract the electrons much more stronger. And the third one is increasing the number of mobile electrons. Obviously, when the number of electrons will be greater, there will be greater electrostatic force of attraction. And you know, the bond will become more stronger. Thanks for watching my video. And don't forget to subscribe and press the bell icon.